This review for the final exam, semester 2, will cover Unit 4. This is all about Newton's laws of motion. So goal 4.1 is just knowing what the laws are. So Newton's first law of motion is the law of inertia. It's also called the law of inertia, but it is C. Objects at rest stay at rest, objects in motion stay in motion. Newton's second law is just the relationship between acceleration, force, and mass. So it's the B, mass acceleration. So the next one, Newton's third law, is for every action force, there's an equal and opposite reaction force. So this is sometimes known as the law of action and reaction. Goal 4.2 is predicting what will happen for resting and moving objects using Newton's first law of motion. So if you have an object moving on a very smooth ice rink, which would mean frictionless, and if the object doesn't bump into anything, what will happen to the object as it continues to move on the frictionless surface? Basically, it's just going to continue moving on at a constant velocity. So it's continue moving on at a constant velocity. So Newton's first law, objects in motion stay in motion. Okay? The second question, what would happen to a rock sitting on the ground over time, assuming there's no forces acting on it? It would just continue to sit there. And not move. Okay, because that's the second part of Newton's law. Objects at rest, objects in motion stay in motion. Inertia is defined as the tendency, that's an E, sorry, the tendency for an object to maintain its state of motion. So if an object is moving, it has the tendency to stay moving. If an object is at rest, it has the tendency to stay at rest. So you would say objects have inertia if they're just sitting there. And which would have more inertia, a 200 kilogram rock or a 20 kilogram rock? The bigger rock would have more inertia because it's more massive and it would be harder to move it. So you would say the 200 kilogram rock has more inertia than the 20 kilogram rock because it has more mass. So the 200 kilogram has more mass. And mass is directly proportional to inertia. So the more mass you have, the more inertia you have. If thrown, which rock would be harder to stop? Well, the more massive one would be harder to stop because it's got more mass. So the same idea, even if it's moving, the 200 kilogram has more inertia because it is more massive. Right. Moving on, goal 4.4 is determining whether or not objects are inversely or directly proportional. So we use the thumbs up, thumbs down kind of idea. If both of them are up or both of them are down, then it would be directly proportional. But if one is up and the other is down, inversely. So the taller the tower of blocks, so think of that as being a bigger thing, the less stable it is. So this would be inversely proportional. The lower the sun is in the sky, the lower the temperature. So both of those are down, so this would be directly. Maybe it'd be better to put this underneath because it matches the question. Here it would be taller the tower of blocks, the less stable it is. That makes more sense. All right, and then the amount of sales tax in Illinois, like if you went in and bought something at a store, Is that in any way related to how many people are in your family? And the answer is no, relationship. So you have to have some kind of pattern between the two. The next one is using the formula W equals M times G. W stands for weight, M stands for mass, and G is that acceleration due to gravity, which is always 10 meters per second squared. Unless you're on a different planet. But on Earth, it's always G. It's always 10. So what's the weight of a 50 kilogram piece of iron? You would plug in the mass. We know kg is mass. Those are the units we use. So we're going to place 50 in for M, 10 in for G, because it's always 10, and you get 500. The units are newtons for weight because it's a force. If you have a weight given to you, then you have to make sure you plug the weight in for the W. So the 70 gets plugged in here. You're looking for the mass. G is always 10. So now you have to divide by 10. If you divide both sides by 10, then 70 divided by 10 is 7, and the mass equals 7 kilograms. The next goal is to describe the relationship between mass, force, and acceleration. And basically, if you look at the equation, which we're going to use next for the next goal, but this is Newton's second law, acceleration is force divided by mass. So if you were to increase your force, so picture putting in a bigger number for F, like say 2, and keep the mass the same. So if you doubled the force, 2 divided by 1 is 2, your acceleration would also double. So that's 2 thumbs up. The increasing force, so if you increase your force, you increase your acceleration. So what does a graph like that look like? Well, oh, I've got this wrong. That's mass and acceleration. So hold on. That would be, in this case, so this is actually here. All right? If you increase your force, you increase your acceleration. And they want you to draw a graph that shows it. So that one, what you would do is you would say, hey, if this is if I'm increasing my force, my acceleration goes up. Directly proportional has a graph that looks like this. For this one, they want to know mass and acceleration. So that's the same reasoning, but if A equals F over M, in this case, we let's say double the mass, but keep the force the same. So you can see if you double the mass, your acceleration actually goes down. It's only half as much. So the way the graph looks like is letter D. As mass increases, your acceleration goes down. So D is the correct graph for number 13. Goal 4.7, you're just using the formula acceleration equals force divided by mass. If they give you kilograms, we know that's a mass. Force, they give you newtons, those are the units for force. So we're going to plug in 20 for force, 5 for mass. 20 divided by 5 is 4 meters per second squared. Those are units for acceleration. The next one, they're going to give you, it takes 100 newtons of force with an object of 10 meters per second. What's the mass? So our unknown is down here in the denominator. So we're going to plug in 100 newtons of force. A is 10, so I plug it in for A. Acceleration is 10, and I'm looking for M. So there's 2 ways to do this. A lot of you like to use the cross multiplication and division. So if I think of 10 as being over 1, then I'm going to multiply the cross products, I guess they're called. So 100 times 1 is 100 equals 10 times M. And then you can see I just divide by 10, both sides, and my mass turns out to be 10 kilograms. The other way to do that, if I set it up again, 100 newtons is on the numerator, I'm looking for M, and I know acceleration is 10. The other way to solve this is just multiply both sides by M. You can do that because you're not changing the value. The M's then cancel out over here, and then you have M times 10 equals 100. Just divide by 10 on both sides, and you get the same answer. So whichever way you're more comfortable with. The next one is interpreting a free body diagram to solve a Newton's second law problem. And for this one, you have to remember how to find a net force. So remember, when the forces are acting oppositely to each other, and you can see that this one's pushing to the right with 5 newtons, this one's pushing to the left with 3 newtons, you have to subtract them. Because what's the overall net force? Well, the 5 newton one is going to win by 2 newtons. So it basically becomes a subtraction problem. 5 minus 3 equals 2 newtons. So the net force is 2 newtons, and actually we need to put the direction there. The direction would be to the right. To calculate acceleration, we're just going to take force divided by mass. So our force is 2 newtons. We just calculated it. Our mass would be 2 kilograms. 2 divided by 2 is 1 meter per second squared. The next problem, they say a 15 kilogram box is being pushed across the floor with an applied force of 50 newtons. The friction force is going to act the other way, 5 newtons. So we're going to subtract the 2 to get the net force. 50 minus 5 equals 45 newtons. So the net force would be 45 newtons. The way I drew the picture, it doesn't really specify, but I would say to the right. Calculate the acceleration of the box. A equals F net. We don't always write that, but that's what it is, over M. So our net force is 45 newtons divided by a mass, and they have to give you the mass somewhere, and there it is, 15. So divided by 15 kilograms, and that ends up being 3 meters per second squared. 45 divided by 15 is 3. And the last problem, the last goal, is identifying a pair of action and reaction forces. So if we look at something like a cannonball that's dropped off this tower, there are 2 forces acting on it, or there's 2 forces involved. This is Newton's third law. For every action force, there's an equal and opposite reaction force. So an action force, in this case, would be the Earth is pulling the ball down because of gravity. The one that's harder to picture, but is happening, is the cannonball is actually pulling up on the Earth. We don't see this as visually as we see the ball falling because the Earth is so massive compared to the ball. If we look at the next one, the action force would be the man pushes, and he's pushing left, so pushes left on the box. The reaction force would be the box pushes right on the man.